In modern test theory or item response theory, IRT, we focus on building models to effectively fit the data we have gathered. To begin with, it's important to determine how many traits you want to evaluate. In many cases, a test assesses just one trait, which usually revolves around a student's mastery of the course content. However, if your test aims to evaluate multiple traits, such as both the understanding of the course material and numeracy skills, then you would select 2 traits for analysis. For the purposes of this demonstration, we will stick with evaluating just one trait. As we proceed, we will look at the figure that displays the item infit and outfit statistics. If you happen to notice that this figure is not appearing, it might be because you have items where all students selected the same response option. In such cases, you will need to remove those items from your analysis. Given the number of items we're dealing with, we might find that the figure appears quite cramped. To improve readability, let's make the figure taller. We can do this by adjusting the slider in the side panel. After making that adjustment, we can clearly see the item IDs and analyze the data more effectively. Let's delve into the concept of item infit, which is also referred to as information-weighted fit. This measure predicts how well an item performs among students whose ability levels are close to the difficulty level of that item. The underlying assumption is that items close to a student's ability should align well with the model's expectations. If an item does not adhere to this assumption, it will yield low or high infit values, suggesting a misalignment with the model. Low infit values indicate that students' responses are highly predictable, meaning they tend to either consistently answer the item correctly or incorrectly. This predictability can occur when an item is deemed too easy or too hard. These item ID are grouped together down here. As we examine the item IDs grouped together in our data, we note that there aren't any items with high infit values. If we did find such items, it would imply that student responses are too unpredictable or erratic. This unpredictability may arise from items that are ambiguous, easily misinterpreted, or demand knowledge that falls outside the scope of the test. Consequently, this could lead students to guess randomly, which contributes to the unpredictability of their responses. Next, let's move on to the item outfit model, known as outlier-sensitive fit. This statistic predicts how items perform across the entire spectrum of students, including both low and high performers. Similar to infit, it operates on the assumption that all students should respond in a manner that aligns with the model's predictions. Upon review, it's evident that several items are listed with low outfit values. A low outfit value suggests that these items are too predictable for all students, particularly for both low and high performers. This predictability could indicate that the items are overly straightforward or that the distractor options are not functioning effectively. We also observe that there are no items with outfit values exceeding 1.5 in our analysis. Should we encounter such items, it would highlight that the item responses are excessively unpredictable. For example, a low-performing student might answer an unusually difficult item correctly, or a high-performing student might fail to answer a simple item. Such unpredictability can stem from guessing, carelessness, or a misalignment between the item and the trait being measured. Through this analysis of infit and outfit statistics, we can gain valuable insights into the performance and effectiveness of our test items, ultimately enhancing our understanding of how well our assessments align with the abilities they aim to measure.